In this lecture, we'll be discussing the Pythagorean Theorem. One important application of square roots has to do with right triangles. A right triangle is a triangle in which one of the angles is a right angle, which measures exactly 90 degrees. The hypotenuse of a right triangle is the side opposite the right angle. It is the longest side of the triangle. The legs of a right triangle are the other two sides. The Pythagorean theorem relates the three sides of a triangle to each other. One of the legs squared plus the other leg squared is equal to the hypotenuse squared. Please note that, as mentioned before, the hypotenuse is the side that's always directly across from the 90-degree angle. Some people teach the Pythagorean theorem a squared plus b squared equals c squared. I don't like this way of remembering the Pythagorean theorem. It doesn't tell me that people really understand what the variables a, b, and c represent. So I encourage you to remember it: leg squared plus leg squared equals hypotenuse squared. Let's find the length of the missing side of the following triangles. We'll round to the nearest hundredth if necessary. I recommend you start by identifying which side of your triangle is the hypotenuse. The hypotenuse is always directly across from the right angle. So in this first example, the missing side is our hypotenuse. I'm going to label it the variable h. Now I'm going to use the Pythagorean theorem to solve for the hypotenuse. Pythagorean theorem states leg squared plus leg squared equals hypotenuse squared. We plug in the numbers. 12 squared plus 16 squared equals our hypotenuse squared. Squaring 12, I get 144. Squaring 16, I get 256 equals h squared. Adding those like terms on the left side, I get 400 is equal to h squared. But we don't want to know what the hypotenuse squared is. We want to know what just the hypotenuse is. So we want to know what number squared gives us 400. That's the same thing as finding the square root. So h is going to be the square root of 400. The square root of 400 is a perfect. We end up with 20 is equal to h, which means that our hypotenuse measures 20 feet. Let's take a look at the next example. Again, I'm going to start by identifying which side is the hypotenuse. The hypotenuse is always straight across from the right angle. In this example, 13 is our hypotenuse. That means that our missing side is actually a leg. I'm going to label that with an L. The Pythagorean theorem states leg squared plus leg squared equals hypotenuse squared. Let's plug in our values. We have one leg that's unknown. I'm just going to leave that L squared plus the other leg, which is 5 squared equals our hypotenuse, 13 squared. I'm going to square my two numbers. This gives me L squared plus 25 equals 169. I want to solve for L. I want to get that variable all by itself. I'm going to subtract 25 from both sides. Gives me L squared is equal to 144. But again, I don't want to know what L is, or L squared is. I want to know what just L is. I want to know what number raised to the second power is 144. That's the same as finding the square root of 144. Square root of 144 is 12, which means that our leg is equal to 12 inches. Let's take a look at a couple applications that would involve the Pythagorean theorem to solve. The base of a 15-foot ladder is 5 feet away from a wall. How high from the floor is the top of the ladder, round to the nearest hundredth? I would start by drawing a picture. I have a wall, the ground, and a 15-foot ladder. The base of the 15-foot ladder is 5 feet away from the wall. This distance is 5. We're assuming that the wall and the floor form a 90-degree angle. And I want to find out how high from the floor to the top of the ladder, what this distance is right here. This is my unknown. So essentially, I have a right triangle with a hypotenuse of 15, one leg of 5, and one unknown leg. We'll use Pythagorean theorem to solve. Leg squared plus leg squared equals hypotenuse squared. Our first leg is unknown. We'll leave it L squared plus 5 squared equals 15 squared. Squaring our numbers, we get L squared plus 25 equals 225. Solving for L, I need to get the L by itself. We'll subtract 25 from both sides. This leaves me with L squared is equal to 200. I don't want to know what L squared is, but I want to know what L is. We want to know what number raised to the second power is equal to 200. That's the same as finding the square root of 200. 200 is not a perfect, therefore we're going to have to use our calculator to find this. Plugging it into our calculator and rounding to the nearest hundredth, we get L to be equal to 14.14 feet. A football field is a rectangle measuring 100 yards by 53 yards. Draw a diagram and find the length of the diagonal of a football field to the nearest yard. We start by drawing a rectangle. By definition, a rectangle is a four-sided figure with two sets of parallel lines, and all of these are right angles. The football field measures 100 yards by 53 yards, and we're asked to find the length of the diagonal. That's our unknown. Essentially, we have a right triangle with one leg of 53 yards, another measuring 100, and the hypotenuse is unknown. We'll use Pythagorean theorem to solve. Leg squared plus leg squared equals hypotenuse squared. Our first leg is 53, our second leg is 100, and our hypotenuse is unknown. We start by squaring our numbers. 53 squared is 2,809. plus 100 squared is 10,000. Combining our like terms on the left, we get 12,809 is equal to h squared. To find out what h is, we need to take the square root of 12,809. That is not a perfect. We plug it into our calculator. We get 113.176852. That's equal to our hypotenuse. The direction says to round to the nearest yard. So rounding to the nearest yard, we get that the hypotenuse is 113 yards.